from our side, from Shihaks KE is also here. And yes, we're just going to wait 2 more minutes and then we can begin. Okay, so I am going to introduce our speaker for today. His name is Abel Ombonyo. He is a student at the University of Nairobi pursuing a master's in distributed computing technology. He has a number of VMware IT Academy digital badges, namely cloud and virtualization concepts, network virtualization concepts, and software-defined storage concepts. He also has a certification in CCNA, routing and switching, and he has over a year experience with vSphere environment, which is a cloud computing virtualization platform for VMware. And today he'll be taking us through an introduction to software-defined networking with VMware's NSX. Welcome, Abel. You can take it from here.
Okay, thank you. Okay, good evening, everyone. Thank you for joining. And I personally wish to thank SheHacks community for giving me this opportunity to present. So let me begin by sharing my screen. Okay, so the topic of today's presentation is about just an introduction to SDN with VMware's NSX. So under the objectives of what I intend to convey today is, first of all, look at an overview of SDN paradigm and how VMware have implemented SDN. I'll also look about the architecture of VMware's NSX, which includes the management plane, control plane, and data plane. I'll also have a look at NSX Edge and the use cases of NSX. Finally, I'll finish by doing a demo. Okay, okay. So the design and implementation of traditional networks, which was built with multiple tiers of static Ethernet switches and routers arranged in a tree structure, mainly what was termed as monolithic design, became insufficient to cater for large amounts of traffic. So These large amounts of traffic were as a result of a proliferation of new technologies such as big data, SDDC, just to mention a few. So this concept, this idea led to a new network design, which was able to decouple or to separate the forwarding plane from the control plane. The forwarding plane is also known as the data plane. So that is where SDN emerged, which is not really a new concept. And the main focus of it was to separate the control plane from the data plane, just as I have explained. So in the next slide, before I continue, I can just show a simplified view of SDN architecture. This I borrowed from OpenFlow, which was one of the companies that were the first to implement the architecture of SDN. From the image, you can be able to see the data plane, which consists of the forwarding devices. The forwarding devices, these are the switches and the routers. And then we have the control plane. The control plane is mainly used to push commands to the forwarding devices. That is the data plane. So you can also have a concrete definition of what SDN is, which I borrowed from research work by Hakiri and others, which was published on IEEE. Back to my design, back to my overview of SDN. So the the concept of SDN led to a shift from static network implementation to a much more vendor-neutral design. You can say initially you are able only to if you are choosing one vendor, for example, Cisco, you'll be able to stick with it. But with the design of SDN, you can be able to do a vendor-independent network design. So several organizations adopted SDN. Just OpenFlow, I had initially mentioned it, and we have Cisco SDN, Juniper, and New Age, and finally we have VMware, which is the main talk of today. Some of the use cases of SDN include SDDC interconnection, which is a software-defined data center, and interconnection. Mainly what this means is you can be able to deploy your data center on-premise and have devices in the cloud, and both of them can communicate as if they're in the same network domain. So that is one of the benefits of that SDN introduced. And we have the concept of network slicing. We do also have the concept of network slicing. And then adoption, there was a good research work that was done by Cisco, which I'll be able to share the link with you, whereby he was able to elucidate how SDN has been adopted by organization over time. Because when the term came, not many organizations were in rush of implementing it. So he was able to explain how today's organization are really moving toward implementing SDN. For example, Cisco, they are not really calling it SDN, they are calling it IBN, which is intent-based networking. And also there's a growth of SD1, which stands for software-defined wide area network. My next slide will be about how VMware has implemented SDN using NSX. So in VMware's world, or in VMware's area, they defined SDN as network virtualization. So for us to be able to understand what network virtualization is, we need to be able to understand what virtualization is in the first place. So virtualization is creating a virtual version of something. When most of us, when we hear about virtualization, we only know about server virtualization, for example, using type 1 hypervisors to virtualize servers, or type 2 hypervisors to virtualize servers and storage. but network virtualization has not really hit mainstream attention. So that is what sparked my interest for today's conversation. So NSX started as VMware acquiring a company called Nisira back in 2012, which was a startup that was mainly dealing with network virtualization. So VMware acquired it for quite some money, and in 2013 they idealized the concept of NSX. So NSX stands for Network Security Extensible, and the first implementation of it was to be implemented in a vSphere environment. So basically during that time, the leading technology by NSX, which is vSphere, they wanted to virtualize their network. So that is why they decided to come up with NSX. So at that time, it was mainly for the vSphere environment. That is why there was a version called NSXV. And later on, they transformed to NSXT, which stands for transformable, whereby they want to migrate from the vSphere environment and move to the cloud and also virtual interconnecting physical equipment. Or just to give definition, NSX is a network hypervisor. A hypervisor is a type 1 hypervisor, for example, vSphere or Citrix or KVM, that reproduces complete layer 2 through layer 7 network service in software. So we all understand about the OSI model. So NSX is able to virtualize from the layer 2 all the way to layer 7. So it works by implementing integrated planes, which are the management, control, and data plane. So just to, okay. The management plane gives a single glass plane of control. For the management plane is responsible for managing all the services running in an NSX data center. So I'll be able to explain in depth the remaining concept in the next couple of slides. When we look at the architecture of NSX, there's the management plane, the control plane, and then the data plane. So at the management plane, we have the NSX Manager and the vCenter server and the message bus agent. So I've already talked a little bit about NSX Manager, but the vCenter server is the main management tool in a vSphere environment. So initially there was a one-to-one relationship between NSX Manager and vCenter, but in the latest implementation of NSX, you can be able to interconnect more than one vCenter in an NSX data center. So in the control plane, we have the NSX controller, which in previous implementation, you needed a standalone device for that. But in today's implementation, NSX Manager is able to work both as a management device and also be in charge of the controller cluster. Under the data plane, we have now the distributed devices. This is where now we have the distributed switch, and then the hypervisor kernel modules, which are the VXLAN, DLR, and firewall. I'll be able to explain this in the next slide. Finally, we have the NSX Edge. So just as I had explained, NSX Manager provides a web-based user interface where you can be able to manage your NSX environment, and it installs the kernel module. These are VXLAN. Think of a VXLAN as a normal LAN, but it's extensible. A normal LAN, you can be able to accommodate around 4096, but for a VXLAN, theoretically, it can go up to 16 million LANs. So that is just the power of virtualization. We also have the DLR, which stands for the digital logical router, and also have the distributed firewall. And then it also installs VMware NSX controllers, and it configures ESXi host using the MBA, which is the message bus agent. Just to go back to my slide, we can see in the management plane, we have the message bus agent. This is used as a tool, a protocol for communication. NSX uses MBA to push commands to the data plane. For example, if it wants to install the hypervisor kernel modules, it will have to use the MBA to push the commands through the controller plane down to the data plane. So, and finally, it generates self-signed certificates for secure communication. So the control plane consists of the NSX logical router, NSX controller cluster, and UWA, which is the user world agent. The NSX logical router was an initial was used in NSXV, but with NSXT, just as I have explained, it's the use of it is being handled by NSX Manager. And then the UWA is the communication protocol on the data plane. So if the data plane wants to receive and pass forwarding traffic from the data plane, it uses the user world agent. Just the same way NSX uses message bus agent to push commands to install the hypervisor kernel modules. So finally, we have the data plane. This is where we have the distributed devices. So we have the VDS, which is the virtual distributed switch. Let's say we are running our software-defined data center on one ESXi host. Think of an ESXi host as a physical server, but we have multiple different servers. So virtual distributed switch, you are able to install different VMs on different servers and be able to communicate with them, be able to communicate on different ESXi hosts without touching the physical network. We have the NSX Edge. The NSX Edge is responsible for north-south traffic. For example, you want to communicate from your ESXi host to the physical network. That is why you use the NSX Edge. And we have the VXLAN, which is mainly for switching, just as I had explained, but it is being superseded by the Geneva protocol. We also have the DLR and the firewall. So NSX Edge, that as I had explained, is used for north-south traffic, which is basically traffic from your NSX data center through the physical network. So there are some services which you cannot be able to implement within your NSX data center. That is, for example, you need to do some routing, both dynamic and static. These services can only be attained by the NSX Edge. If I can just go back to my architecture, you can see that NSX Edge is at the bottom of the control plane. So it is responsible for doing the functionalities which cannot be attained by the NSX data center. Think of this implementation as running inside an ESXi host, just as it's located at the bottom. And then, okay. So if you are given a task of deploying the NSX infrastructure, the way to go about it, first of all, you will have to deploy the NSX Manager cluster. This you will be able to attain using the Compute Manager. The Compute Manager is the vCenter server. I'll be able to display this in a much more easier to understand when I'll be visiting the GUI. And then after you install the NSX Manager, you deploy the controller cluster. This is done inside the NSX Manager. And number 3, you deploy the transport zone. This is now the overlay. Overlay is the concept of distributed services, distributed services. And then you deploy the tabs. The tabs are the tunnel endpoints for hosts to communicate with each other. And then finally, you will create your logical switches for VMs to communicate with one another. So this is how traffic flows inside an NSX data center. We can see we have 4 different we have 4 different servers, and we have 2 subnets. Let's say a host on VM on a VM on host 1 wants to communicate with a VM on host 2. First of all, it will send a frame to VM2, as you can see in the diagram, and then it will use NVDS, which is NSX Virtual Distributed Switch on host 1, will look up the MAC addresses on of VM2 and hit a tunnel endpoint on host 2. And then the frame is encapsulated. And then the frame is encapsulated, and then tunnel destination IP of, I think it's yeah, there's a, okay. The frame is encapsulated, then the tunnel destination is the IP of the tape on the host 2. Finally, the tunnel packet is routed by the physical infrastructure back to host 2. And then how is routing achieved? First of all, you create a logical router, and then you create a downlink connection to different switches on both hosts, and then finally you test the connectivity. I'll be able to explain this further in my demo. So use cases of NSX. The first one is security through microsegmentation. Microsegmentation is VMware's attainment of the zero trust model. Number 2 is multi-cloud networking. This is whereby you can be able to deploy your SDDCs in private cloud and be able to merge or communicate or interconnect with devices connected on the public cloud. VMware is able to attain that. And finally, there is automation. Automation in terms of management, you can be able to incorporate automation tools such as Terraform, Ansible, vRealize automation to achieve your automation purposes. So the demo that I wanted to do is, first of all, to interact with the NSX Manager or the GUI and showcase the key concept that I have just trying to explain. If the concepts were not clearly explained to you, I will be able to see them in a graphical user interface, so you will be able to relate. And then I'll be able to try to use a Terraform to deploy a network architecture. So let me just share my second screen. Okay, so once you log in into your NSX Manager, first of all, one thing that I had failed to mention is that NSX is a licensed product, and this somehow hindered my demo, but I'll just proceed on with it. Okay, so once you log in into your NSX Manager, this is what will be displayed to you. On the home page, there's a couple of things you can take a look at. Currently, we can have your distributed firewall policies are located under security. On the system, you'll be able to see the services that have been deployed. Currently, we have 5 transport zones, and we have 0 edge transport nodes. We also have the node cluster. This is now the 3 node cluster that I initially talked about when you are trying to deploy NSX Manager and use it as a controller cluster. So currently I have 2 deployed, but it is recommended to have at least 3, so that one is acting, it is recommended to have 3 so that you can be able to install them on different ESXi hosts. In case one goes down, the network is able to be you can still manage your network. So under networking, this is where you can be able to see all your services all the network architecture that you have deployed. You're able to see tier 0 gateways, tier 1 gateways, segments. Segment basically means the switches, logical switches. And then under security, you can be able to see various security components. For example, you can be able to perform your intrusion detection, east-west traffic. What east-west traffic means is the traffic within your NSX data center. You can also be able to perform URL analysis summary. So this is just the security aspect of NSX. When you come to system, this is where you will be able to manage your licenses. You'll be able to connect with the vCenter server. So you can come to Fabric. Under compute managers, this is where now you can be able to link your the devices in the management plane, just as I had shown in the architecture. So for this case, I had already done that. So this is now the vCenter server. This is now the interconnection between the devices in the management plane. vCenter server is supposed to manage a vSphere environment, and NSX manages a NSX data center environment. From this GUI, you can be able to deploy all your architectures, but for some for some system administrators, it is much more easier to deploy your architecture through code. So that is now the second part of my presentation, and I'll just head over to VS Code, and I will take you through the code that I had created. So Terraform is a configuration management tool. It's not a programming language. So it's a tool classified under what is known as infrastructure as code, which you can be able to use Terraform to manage your infrastructure. It has several deployment platforms. You can be able to manage services on vSphere. You can be able to manage services on cloud platform, for example, NSX, Microsoft Azure, and GCP, among others. You can also be able to manage even devices on Parallels and VirtualBox VMs. So, but for this case, we are using a provider of NSXT, which is our network virtualization platform. So how Terraform is built is categorized into three concepts. We have the provider. The provider now is the platform, the deployment platform, which manages the life cycle of a resource. So for example, our resource for this case will be our deployment platform is NSX. So the next thing is the data source. The data source allow data to be fetched or computed for use elsewhere in the Terraform code. So in this case, we have our transport zones, and we have our logical routers and the NSX Edge cluster. And then another thing we have now, apart from the provider and the data source, we have the resource. The resource are components of your infrastructure, which lifecycle we want to manage within Terraform. So for this case, we can be able to manage our logical switches, our logical routers, and then this is a tier 1 logical router. And a couple of these are from logical routers. Can also be able to create virtualized ports on both the switch and the router. This is a logical port. And then you can also be able to create a downlink. A downlink is a interconnection within the NSX switch inside the NSX data center. So just like I had mentioned earlier, NSX is a licensed product, and for the purposes of this presentation, I had used evaluation copy of it. So most of the components that I have written in my code will not be able to be created because I haven't provided a license for it. For example, let me just show you. I cannot be able to create tier 0, gateways, tier 1, a lot of things. So just to make for you guys to understand how this is done, I can be able to do this demonstration in a vSphere environment, whereby I will automate how you can be able to generate multiple VMs at the same time using code. So I'll just show you my vCenter server. So the good thing with Terraform as a configuration management tool, the documentation is readily available online. So it's very possible for you just to teach yourself how to manage an infrastructure. So in a moment, let me just load my vSphere environment. So currently, in my infrastructure, you can only see we have 5 VMs, only 2 are running. So I want to try to automate the generation of multiple number of VMs using code. For example, if a use case for this may be, you may be tasked as a system administrator to deploy 50 virtual machines. If you are supposed to do this manually, it will take quite some time. But if you automate, it will be quite easier. So that is what I want to demonstrate. And I want you guys to relate that to deploying an NSX infrastructure, because the procedure is the same, the implementation is the same. All devices are virtual. It's just that I currently do not have the license for NSX. So the concept is the same. There's a provider, which is vSphere, and I want to deploy some services on the data center. So the data store is the storage, and then the cluster. The cluster is the ESXi host where you wish to deploy your machines on. And then you have the network. How will your machines be interconnected with each other? And then you finally create your VMs. So you can be able to specify the number of VMs you want to simultaneously create. You can be able to create 1 VM or create up to 100 VMs, depending on the resources on your machine. For the purpose of this demonstration, I'll just like to deploy two or three virtual machines. Let me just go back to you can see there's nothing deployed here. So I know I've been moving very fast, but please feel free to ask any questions after I finish my presentation. I'll be happy to answer. So we can be able to see there are two Ubuntu machines that are being deployed. So this should not take quite long. You can imagine if you are configuring this manually, clicking your way through installation, it will take quite some time. So it has only taken a few minutes, and our machines are being deployed. You can see this one of them which is completed. You can see one of our machines is already complete deployment. So the main idea for me to do that was just for you guys to relate this to deploying a network, because the idea is the same, the product is the same. So the network devices and the machines on the NSX data center are deployed the same way the virtual machines inside the vSphere environment are being deployed. So let me just go back to my presentation. So that marks the end of my short presentation, and I like you guys to ask a lot of questions, because I've really rushed through a lot of concepts.
Any questions, guys?
Okay. One of the questions is, are there any advantages of Terraform over Ansible? I will say, for me, okay. For other people, it depends on preference, but for me, I'll go for Terraform, because um, Terraform has been, it is considered the primary tool for infrastructure as code. You can be able to do so, but for others it's about preference. But for me, I'll go for Terraform. But another thing you should look at is, it is easy for you to destroy an architecture that you have built using Terraform than you can do with Ansible. For example, if I want to destroy what I've just built, okay, let me just go back to my,
I have a question. Let me ask, is there a way you can automate, despite having Ansible here, is there a way you can now automate patches and items like that, or will we be reliant on Ansible also?
Okay, nice question. So for automating patches, that is now it's called provisioning. After you have deployed your machine, you have to provision it. And provision it, there are several ways of provisioning. either incorporate Chef as a provisioner so you can use Chef for running your updates. So that is the best way I can answer your question.
Sorry, can you type that name on chat?
Chef. Okay.
Like a chef or a cook or something like that.
Yeah, CHEF. They are quite okay. There's Chef, there's Puppet. You can be able to use PowerShell for provisioning, Bash. So you can be able to incorporate this inside Terraform. So it's not just one tool.
Thank you.
Yeah, you can have the notes. I can share.
I'm not sure we have more questions. Is there anyone with any additional questions? Maybe Laura, you still with us? Maybe you can say something.
Yes, sorry. Do we have any more questions? Is this a new, maybe I can ask the participants who are with us today, is this a new field? Is it new information that you're getting today? You can unmute yourself and tell us. Oh yeah, so John is saying this is a new field. Yeah, I am. We've never had this session before, a session like this before. So I am sure for some people, especially for beginners, this might be new information. But we're very glad that Abel has been able to join us today to introduce us to this. And hopefully, yeah, Lawrence is saying it's so new. Hopefully, Abel will be able to have follow-up sessions. I know now that you've opened or given a foundation to the people, to our attendees, they'll be able to go read up on it, learn something new, and maybe we can have a follow-up session when most people are familiar. But yes, this has been a very good session. We also have it airing right now live on YouTube. So please feel free to share it with anyone you know would be interested in learning, and we can push the conversation forward. Eve?
I don't have much to say. Maybe I can just request able to do another session, and I'll be glad to have another one. I liked the approach, maybe because of what I do, but I really liked it, and it makes your work easier when you're spinning up VMs and things like that. Yeah. So not much more. I wish everyone a good night. We can now adjourn the meeting today.
Thanks so much, Abel. We hope to see you soon, and good night, everyone. Thanks for attending.
Thank you. Good night.